Hello and welcome to Adding and Subtracting Radicals. I know you've been wondering, we can make radicals smaller and we can multiply them, but how do you add them? How do you subtract them? Is that even possible? So I'm here with answers to some of those things. If we have something like square root of x plus square root of x, is that even possible? And the answer is yes, this is possible. This is saying I've got one root x plus another root x. I've got one over here, I've got one over here. If I just put them together, how many square roots of x do I have here? 1, 2. This gives me 2 square roots of x. We know that if we have square root of x times square root of x, a square root times a square root equals this square root squared, which ends up canceling and being a plain number. But with adding, we're just counting up what it is, how many of them we have. With multiplying, we change what it becomes. So if I've got a root over here, and a root over here, and a root over here, and they're all root x, I'm just going to count up how many we have. It doesn't work the same, though, if I've got root x plus a root y. This tells me I have one of these and one of these. It's not two of any of the same thing. If I had another root y, then at least I've got two of the same thing, so I can say, well, now I've got one root x, then I've got 2 square roots of y. It's just counting up the ones that are the same, and this might start to sound like terms. And it is. 2 radicals are like radicals if they have the same, let's see, what's the thing called underneath here? In the radical, the part that's underneath here, we've talked about this before, it is called the same radicand. So they both have to be x's or both have to be y's. We can't have one x and one y. The other thing, though, is that something else has to be the same as well. What about this? Square root of x plus cube root of x. Well, now I've got one square root and one cube root. They're different. I cannot say I've got 2 of the same thing. And this number up here, remember, is called the index. So as long as they have the same radicand and also the same index, we can say that they are like radicals. This word could also be root, right? They must be the same root. Cube roots. Now, if I have 3 cube roots of x plus 4 cube roots of x, same radicand, same index. I got 3 of you guys over here. I got 4 of you guys running around over here. Get them all together. 1, 2, 3, 4, 5, 6, 7. I've got 7 of these cube roots of x. Okay? So if we have numbers like this, one of these is okay, one of these is not. One of these I can put together and solve and combine and count. One of them I cannot. Pause for a moment and look at this and see what you think. Which one can be added together and which one cannot? Now that you've made your guess, play the video. And let's see, does this one have the same radicand and same index? Yes, so there's 1 root 2 plus 3 more root 2's. This gives me 4 root 2's. Over here, this is a root 2 and this is a root 3. They are different. We've got 2 of one kind and 1 of another, so they can't be simplified. They just sit there next to each other, pretending to be friends, but they're not the same thing. Okay? So a problem like this is really where we're headed to. It looks like on the surface that we can't do anything with it. Because you just said, Mr. Bibbs, the same radicand, they have to be the same. 8, 2, 18, all different, nothing we can do, all finished, no more math. But what we need to look for is, can we change these and make them smaller? That's the first thing to always check for. 8 can go to 4 and 2, and 2 and 2, and these are all square roots. Do I have a pair of squares? Yes, I do right here. That's a plane 2 plus this plane 2, or times this plane 2, with 1 radical 2 left over. So 2 root 8 is really 4 root 2. Oh, I got another root 2 over here. It's going to like this answer. And now what about root 18? We got 9 and 2, 3 and 2, 3 and 3. Root, root, root. Do we have a pair of squares? Aha, here's a 3. And we've got another plane 3 from up here. And we've got 1 radical 2 left over. So this makes 9 radical 2. Now you see the game has changed a little bit. We thought they were all different radicands, but really once we simplify, they are all the same radicands. Now we can combine them, we can count them up. The radicands won't change, it's still square roots of 2, it's just a matter of how many. 4 minus 3 is 1, 1 plus 9 gives me 10. Okay, so you see we need to simplify and then look to combine. Alright, try this one. Can you do this one? Pause it and try it, and then check my answer. And play. This one we can make it break down to 9 and 2 and 3 and 3. So we've got this, which is plane 3 times plane 2 with a root 2 left over. So this is 6 radical 2. We've got root 12, which is 4, 3, 2, 2, root, root, root. That's a plane 2 with a radical 3 left over. Uh-oh, not the same. Oh, but here's another 5 root 3. He's going to like the 2 root 3. They can be friends. And over here, 4 and 2, 2 and 2. There's a plane 2 with a radical 2 left over. Oh, he's going to like this guy over here. So let's put together the ones that are like radicals. The 6 radical 2 and the 2 radical 2. We have a total of 8 of these radical 2's. And then here we've got 2 radical 3's and 5 radical 3's, and that gives me a total of 7 radical 3's. If you got this answer right before you watched me, congratulations, give yourself a pat on the back. One more to try, and then we're finished. Try this, pause the video, and go, and start. If you got this for an answer, you can stop the video and you don't need to hear me talk. If you didn't get this for an answer, or you never paused it, then you got to keep on rolling and listen to me go. We're going to try this one together. This one, 3 is as small as I can make it. 27 I can make smaller. 3 and 9. Here's a pair of 3's. We have a plane 2. And we've got a radical 3 left over, so this is 6 radical 3. This one was 2 radical 3. This one, how about 8 and 6, and 4 and 2, and 2 and 2, and 2 and 3. Square root, square root, square root, square root, square root. We have pairs of squares going on. Here's a pair. This makes a plane 2. Here's another pair. That's another plane 2. This guy's extra. So we've got 4 radical 3, and it was subtraction. So 2 plus 6 of these radical 3's gives me 8 radical 3. And 8 radical 3 minus 4 radical 3 is 4 radical 3. We did it. We can add and subtract. Have a great day.